Now, we have one or few points, one or two things, but let me look at this. Metal plus nitric acid in concentrated nitric acid you get NO2. Dilute nitric acid you get NO. Very dilute you get ammonium. Listen to me. We have 80 metals. Listen to me carefully. Don't blame me later. We have 80 metals. 3 different states of nitric acid. 3 different concentrations of nitric acid. A total of roughly 240 reactions. There are some 7 exceptions to this. Concentrated most of the time you get NO2. Dilute most of the time you get NO. Very dilute you get NH4 plus, with a few exceptions. I am even writing that, with a few exceptions. With a few exceptions, sometimes this may not happen. Sometimes this what might happen, I don't know. With a few exceptions, right? And don't learn those exceptions. Don't learn those exceptions. You just go by generalization. Most of the reaction you will be right. 75% of the time you are right. Maybe on one occasion you are wrong. So you have plus 75 minus 25 by 3. Negative is only 1. You still have plus 66%. Plus 66%. You should be happy with that. A paragraph was given in 2009 where concentrated dilute states are asked. 4 are given. 3 are correct with this. NO2, NO, NO2, NO. 1 is wrong. Which one is wrong? I don't know. I will never say. Don't learn those exceptions. If you want to learn at your own risk. If you want to learn those exceptions, do that at your own risk. I will not teach them. I myself do not know them. Why? If I teach you those 7 exceptions, what happens is, when you actually go into an examination hall, everything seems to be an exception. Suppose if I say copper, nitric acid, concentrated. I haven't taught anything. What should you write? NO2. But if I teach you those exceptions, what will happen? Yes, I remember. R Satyanarayana Sir has said copper is an exception. I never said any exceptions. Okay? So for everything will appear an exception to you if you learn those few exceptions. If you learn those exceptions, everything appear, because it's humanly impossible to remember 240 reactions. If you want to do that, okay, I have no objection. Those who have the ability to mug up 240 reactions, for them this lecture is not of any use. Or those who have already mugged up all those reactions, those who have learnt unnatural way, okay, you are welcome. But these lectures are meant to those who are struggling to memorize so many things in chemistry, and you blame chemistry for that. You have to memorize so many things in chemistry. Who said to memorize? You know your limitations. And confine to what you can do at your level. If you have the ability to mug up, okay, very few people will have the ability. Oh, definitely you will find 100 to 200 people with exceptional abilities to mug up. They may have photographic memory. Okay, they may even remember the telephone directory, like Rajinikanth did in a movie Robo. So you just turn the pages, you scan them, okay, you are welcome. But these lectures are not meant to those. Remember, those who want to learn chemistry in a natural way, without memorizing, with correct understanding of chemistry, you want to learn, these lectures are useful. At least as far as I am concerned, that is what I can do. I can't do anything beyond that. This is what I tell my classes also. I don't feel any shame in taking I don't know. I simply say I don't know. I am helpless. So copper, nitric acid, concentrated, NO2, that's all. dilute NO. Zinc nitric acid, concentrated NO2, dilute NO. Out of these 4, one may be wrong. Which one is wrong? I don't know. So, in that matching of 8 marks, you still have got 6 marks. 6 out of 8, no negative. And there is part marking, 6 out of 8. Should you not be happy to get 75%? If you are not happy and if you still want 100% chemistry, okay, I am not the source. These, my lectures will help you get a reasonable score in chemistry by spending less time during preparation and during examination, mind you. Less time during preparation, you don't have months and years to prepare chemistry. Neither you have all the 6 hours in an examination. At best you can give 45 minutes to chemistry. Your maths and physics will take more, should take more time, biology, etc. So, if you can give all the 6 hours, perhaps it's okay. If you can read for 24 hours chemistry only, leaving maths and physics behind, okay. But know your limitations. Okay. If your knowledge is unlimited, okay, so there are exceptional people. I am not that type. So, with a few exceptions, I already mentioned that. Why? Why is the case here? Metal. What is the role of a metal? Metals give electrons. Who is nitric acid? What do you think nitric acid? Nitric acid is an acid. Okay. It's like my daughter is a girl. Nitric acid is an acid. What big thing is it? Nitric acid is an acid, gives protons. It's not just protons. Remember, nitric acid is a good oxidizing agent. If you remember the 4 oxidizing agents, KMnO4, K2Cr2O7, HiO4 and HNO3, these 4 are certain oxidizing agents. Therefore, this nitric acid can take electrons, can give protons. Remember, you required an acid to give protons. Here you have the acid that gives protons. And metal is giving electron. Nitric acid, where do oxygens come from? Oxygens come from nitric acid itself. Like oxygens are coming out of permanganate, they are manganese. Here oxygens will come out of nitrogen. You see, the oxygens of nitric acid only are becoming NO2. NO2. Lesson. NO2 means one oxygen is lost. So, it gives oxygens also. So, this is a reducing agent, acid, oxygen, all 3 are there. Batsman, bowler, fielder, all there. Now, start playing. Now, nitrate. Nitric acid in concentrated, what will happen? Concentrated nitric acid, remember, though nitric acid is a strong acid, it also requires water for ionization. You won't ionize in gaseous state. HCl in gaseous state doesn't live the life of H plus and Cl minus. HCl behaves as an acid only when it is dissolved in water, you know as much. So, concentrated means less water, less ionization and less protons. You don't have many protons here. Therefore, concentrated, the nitrate that comes from nitric acid and 2 protons and 1 electron, you get NO2 and H2O. You ask me, sir, why NO2 is formed? Why NO2 is formed? I will tell you, you ask me why NO2 is formed? Because one oxygen has gone away. I will tell you, one oxygen has gone away. Sir, why has oxygen gone away? You know, oxygen has gone away to become water. Sir, why haven't the others gone? Why haven't the other oxygens gone? Why are 2 of them still there? Can't you see? Protons are less in number. A shortage of protons. It's not a shortage of electrons. Metal will give any number of electrons. So, in chemistry, electrons are no big deal. Any metal will give you protons. You require a source for protons. That is why even in the dehydration of alcohols, etc., you require the help of a proton. Remember that. Now, so since in concentrated you have less water, less ionization, less protons, this is it, NO3 minus. So, dilute. dilute HNO3, a few more protons. Dilute means you are adding more water. A few more protons. Few more protons. So what will happen? Here only one O minus is going. O minus requires only one electron. Actually oxygen requires two protons and two electrons. But one electron is already here, minus, minus. So H2O. NO3 minus. 4H plus and 3 electrons. What do you get? Help me. NO3 minus 4 protons, 3 electrons. You get NO and 2 H2O. You ask me, sir, why 2 oxygens have gone away? 2 oxygens have gone away to become water. Then why hasn't the third one gone? Because of the shortage of protons. Always focus on. So what is the difference between concentrated, dilute and very dilute? And the third case is very dilute nitric acid. Very dilute nitric acid. Infinite number of protons, no shortage, no more shortage of protons. Infinite number of protons. Right. So here in this case, NO3 minus, all oxygens will go away taking protons, taking electrons. Look here, all the 3 oxygens have gone out, 3 H2O. For each you need 6 protons, okay, and 6 electrons, out of which 1 electron is already there. So 5 electrons are required for 5 are required for oxygens. Actually 6 are required. 3 oxygens, 6 are required, but you already have 1 minus here. So 5 electrons for 3 water molecules, 5 protons. Then NO3 minus H plus electron. Then here you have a nitrogen. All nitrogens, you remind me, want to become N2. All nitrogens want to become N2. I only said the T. But that is when heated, slight heating. Here nitrogen is among protons and electrons. Nitrogen is in the middle of protons and electrons. It is surrounded by many, it is in a sea of protons and electrons. It cannot escape. So nitrogen becomes ammonia. Like oxygen becomes H2O, nitrogen becomes NH3. And after becomes NH3, it will take one more proton to become NH4 plus. That's why in the dilute condition you get NH4 plus. So how many protons are required all in all? 6 protons for oxygen, 4 for nitrogen, 10 protons. How many electrons are required? 6 for oxygen, 3 for nitrogen, because nitrogen takes 3 electrons and 3 protons to become NH3. H2O means 2 electron, 2 hydrogen means 2 electron, 2 proton. So don't call it a hydrogen atom hereafter. Don't call it a hydrogen atom. You call it a proton electron. That division, that looking at minute things is chemistry. You have to see the invisible. Whatever is visible, physics deals with them. Whatever is visible, but we are dealing with the invisible. So we must have seen that chemistry deals with internal structure of matter. Internal structure, whatever is that internal structure, this is it. So calling hydrogen atom as a proton and an electron, that makes chemical sense. Get into that. So how many electrons are all in all required? 5 for oxygen, because we already have 1, 5 and 3 for, so total of 8 electrons. So how else you can get this? Plus 5 minus 3, 8. That meaningless subtraction. Plus 5 minus 3, difference is 8. Why are you looking at the difference? 8 electrons are required. Why? Why are 8 electrons participating in this? Because there are 3 oxygens who want to become H2O. There is a nitrogen which wants to become NH3. So after all said and done, listen. So what is the message? Just as all oxygens become H2O, nitrogen also wants to become NH3. So oxygen, nitrogen, H2O, NH3, OH minus, NH2 minus, H3O plus, NH4 plus. C double bond O, C triple bond N. All are one and the same. One and the same. Only they vary in their degree of reactivity. Oxygen takes 2 electrons, nitrogen takes 3 electrons. Both are non-metals, but 2, 3. It forms H2O, this fellow forms NH3 because its valency is 3. OH minus is a base, NH2 minus is a stronger base. Why? Oxygen OH minus is still linear, but NH2 minus, you see, it is bent, V-shaped, highly. So, a linear one, OH minus, oxygen OH minus is still linear. Even though 3 lone pairs are there, lone pairs cannot affect one line. What will happen to this? Nothing will happen. The lone pairs repel. What will happen? OH minus here, either here, like this. Means what is happening is linear is always linear. But NH2 minus is not the case with NH2 minus. NH2 minus, N minus, HH. So, 2 lone pairs, 2 bond pairs. So, with a degree of their reactivity, but they both are non-metals. Both are bases, strong base. H3O plus, hydronium ion, NHO plus, this ion. This is more stable because oxygen still has a lone pair, H3O plus. H3O plus, NHO plus is very happy. It got rid of the lone pair. NHO plus is very happy. H2O plus is not that happy because it still has got one more lone pair. Pyramidal tetrahedral. Carbonyl compounds, nitriles, same. Behavior is same, oxygen, nitrogen, one and the same. One and the same. Now, let us apply few things here. First things first. MgSO4 on heating, do you get SO2? Will you get SO2? Think about it. What am I expecting to happen? Sulfur in +6 state to become +4. I see. Sulfur +6 to +2. Okay. You need an agent for a change. You need an agent. You need an agent for any change. Don't forget this. For any change. Change doesn't come automatically. You need an agent. You need a Mahatma Gandhi for independence. It doesn't come automatically. You need a Mandela for the independence of the Africans. Who will do this? +6 to +4. Sulfur has to be brought down from +6 to +4. Will it happen automatically? You need an agent. You need a bowler for you to bat. If you are holding a bat, when can you bat? Only when there is a bowler. So, you are expecting something to happen, and at the same time, you should know whether you have the right person for the job or not. If you want to get insured, you need an insurance agent. Here is it. So, magnesium 2 plus, is it an oxidizing agent? Are you joking? Mg2 plus. Mg2 plus, maximum oxidizing agent. I told you it is a spectator. It is a spectator, therefore doesn't happen. This reaction doesn't happen. But look here, FeSO4, the green vitriol, on heating gives a brown residue. Heating in oxygen or air, brown residue. Okay. And SO2 and SO3. Why? How do you get SO2? How do you get the brown residue? A light green solid, ferrous sulfate, green vitriol. I see. So, who is bringing +6 to +2, +4? Of course, SO3 is still in +6. I am not asking about SO3. So, who will do this? +6 to +4. Do you have the proper agent for that? Yes. Fe2 plus is a branded reducing agent. Did I not tell you? What is the role of Fe2 plus? It gives electrons. Sulfur is forced to take. So, Fe2 plus becomes Fe3 plus. This brown residue is Fe2O3, iron 3 oxide. Iron 3 is important here for me. Iron 3 oxide. Rust. So, iron 2 automatically becomes iron 3. So, in its effort to become iron 3, it loses electrons and sulfur plus 6 to plus 2. So, this reaction is feasible, this reaction is not. So, if you forget this, there is nothing I can do. If I am asking whether this will happen or not, you should look for the agent. Now, so which of the following sulfates on heating give sulfur dioxide, Na2SO4? You get SO2 from this, Na2. Is he a reducing agent? Na2. He is no agent. Don't ask me whether he is a reducing agent, whether he is an oxidizing agent, whether he is an insurance agent. He is no agent at all. He is a spectator. He is no player. He is no player. He is simply a spectator who claps at others. When others play, he watches, enjoys, claps. That's at best he can. He can never play. Spectator. Now, so magnesium sulfate, sorry, and ferrous sulfate, S. So, if you consider that as a reaction that has to be memorized, there is nothing I can help. You see, it is the compound is in front of you, the reactivity, you know, NH4Cl on heating, do you get hydrogen? Small, slight heating, do you get nitrogen? Don't ask me, or don't ask me, you just think about yourself. What do you read? What do you need? An agent. Nitrogen minus 3, 0. Minus 3 to 0 means, oh, you are in the minus 3 floor, minus 3 floor. You want to go to 0, the ground floor. Okay. You need an agent for that. Which agent? One who takes you upwards. He is called an oxidizing agent. Is Cl minus an oxidizing agent? Once again, I told you Cl minus is also almost like no agent. No agent. Why? Cl minus, Cl2, very difficult. Very few people can do that. Very few people can achieve the task. So, NH4Cl and 2. So, no. So, what is the conclusion? Ammonium, this one I copied from a book. Ammonium compounds, I think J.D. Lee. Ammonium compounds in which the anion is an oxidizing agent. Anion should be an oxidizing agent. On heating give, so only those ammonium compounds, not all ammonium compounds. Ammonium compounds on heating give ammonia. Ammonium compound, ammonium chloride on heating gives ammonia. Ammonium sulfate on heating gives ammonia. But other ammonium compounds in which anion is an oxidizing agent on heating give nitrogen. So, when I said all nitrogens want to become N2, I too want to become Prime Minister. Who will make me is the question. Okay, nitrogen wants to become N2, but who will make him? You need an agent for that. Nitrogen in minus 3 wants to go to 0. Someone who takes you up. A person who takes you up is called oxidizing agent. Here you are. So, ammonium dichromate on heating, what will you get? Now, go back to the reactivity. What do you remember? Sir, all nitrogens want to become N2. Okay. But do they have a possibility here? Yes, sir. Dichromate, Mr. Dichromate in plus 6 state. Okay, okay, plus 6. Maximum oxidation state, and you know he definitely acts as oxidizing agent. With others you may doubt. But with permanganate, dichromate and pyridic acid, HiO4 and nitric acid, you are rest assured they definitely act as oxidizing agents. They are branded oxidizing agents. What do I mean by that? Means you need not doubt them. They definitely act. Others, they may or may not act as oxidizing agents. I repeat, others who are in maximum oxidation state may or may not act as, they have a choice. They have a choice of not acting as oxidizing agents also. Like I have a choice of teaching here or not teaching here. They have a choice. But these people, they also have a choice. They can remain that way, or they can act as oxidizing agents. They don't exercise their choice. they simply act as oxidizing agents. You need not doubt them. That is why I say they are branded oxidizing agents. So, ammonium dichromate on heating, you get N2 because you have an oxidizing agent, and all oxygens want to become H2O, 4H2O. Gladly have it. And what remains? Cr2O3. I told you chromium plus 6 or plus 3, the green residue. Green residue. Liquid neutral oxide. Liquid neutral oxide. You know, this is the only liquid neutral oxide, at least in our syllabus. You know, carbon monoxide, a gas, nitrous oxide, neutral gas, nitric oxide, neutral oxide, but gas. H2O is the only liquid neutral oxide in our syllabus. And N2, less reactive gas. I can't say non-reactive gas, but definitely less reactive gas. Chalega. Orange solid. Orange solid. You just remember a few colors. You don't need to remember too many colors, but definitely 10-15 colors you have to remember. Dichromate orange, or chromium 3 green, like that. Chromyl chloride is orange red, nitrogen dioxide is a reddish brown gas, bromine is a reddish brown gas again, or liquid. A few things. The complex of copper and ammonia once again is copper, ammonia is what do you call, deep blue, and iron 3 outside 2 inside, which is called Prussian blue, intense blue, ferric outside, ferrous inside, a cyano complex of iron 2, and the cation is iron 3. Iron 3 is cation, iron 2 is the transition metal central ion with cyanides, that is called Prussian blue. So, you remember 10-15 colors, not more than that. You do not remember, okay. Less reactive gas, why do you write that? I could even nitrogen less reactive, I can even call it an inert gas also. I can go to the extent of inert in the sense less reactive. What else? Okay. So, orange solid on heating gives less reactive gas, liquid neutral oxide, green residue. This is it. X, Y, Z. X, Y, Z, W. Okay. Only those ammonium compounds in which the anion is an oxidizing agent on heating give nitrogen. So, now I am taking up more examples. Na2SO3 plus H2O2. Okay. Na2SO3, H2O2. What will happen? You split Na2SO3, Na plus, spectator, sulfite SO3 2 minus, sulfite pyramidal lone pair wants to become tetrahedral, and what do you know about H2O2? Happily gives oxygen. So, what will happen? He is ready to give oxygen, he is ready to take oxygen. What business we have in between? Na2SO4, H2O. So, all reactions of H2O2, an oxygen atom simply transfers to the other molecule if it is ready to take that, if only that is ready to take that. As simple as that. So, you have all reactions of H2O2 this way only. Look here, a compound containing a peroxy bond, weak oxygen or a similar oxygen chlorine, similar bond, can lose oxygen atoms easily, and it can take oxygen also. Very funnily, H2O2 has an extra oxygen, it can even take an oxygen. Sir, you are saying it already has got an extra oxygen. Don't worry, that oxygen atom, this oxygen will become O2 and H2O. So, I can't send an atom just like that. I can't just send any atom. No atom wants to be in atomic state. It must get company. So, oxygen, O2, good. Or, so H2O2 can take oxygen, reducing agent, can give oxygen, agent, and when this oxygen is given to bacteria dies. Antiseptic. Why? I perhaps do not know. Bacteria, we live of oxygen and bacteria dies of oxygen. I consulted some biology friends, they said it is called anaerobic respiration. I am sorry, I am not sure about that. But Bacteria dies of oxygen. Antiseptic, antibacterial, bleaching agent. I taught you bleaching. Okay. Vegetable matter is colored because of a loosely held oxygen atom, and that loosely held oxygen, this bleaching agent, oxidizing agent, reducing agent, antibacterial, antiseptic, water purifier. Ever heard of ozonized drinking water? Ozonized. What is the role of ozone there? Kills bacteria. What else? Don't tell me absorbs UV radiations. Why do you need absorb UV radiations? It's not necessary in water. So, reactivity is what everything. Reactivity. All oxygens want to become H2O, all nitrogens want to become N2. So, you have a long list. Ferrous is a reducing agent, oxalate is a red branded, and PbO2 is a good. PbO2 is a good what? Good oxidizing agent. Makes sense to this? Why? I already given you the answer. Any question on? Any question on molecules of? Any question on molecules of? Sorry, any question on thallium, lead, bismuth, polonium? You think in terms of inert pair effect, if you remember that. So, PbO2 is a good oxidizing agent. What do you mean by oxidizing agent? I don't know. Reducing agent is one who gives electrons. Reducing agent is one who gives electrons. Start there. Okay. Reducing agent is one who gives electrons. PbO2 is one that takes electrons. Why is PbO2 taking electrons? To become 2 plus. Why? Lead prefers lower oxidation state, which is called inert pair effect. Preferring lower oxidation states and fewer number of bonds is precisely what is inert pair effect. Preferring lower oxidation states and fewer number of bonds. So, PbO2 is a good oxidizing agent. So, like that you can perform any number of reactions. All reactions of H2O2, ozone, CaOCl2 without question. Now, 4P plus 10 N2O. What do you remember about this? N2O means N2. I told you in the reactivity. N2O means N2. So, all these slight heating, 10 nitrogens will get separated. Never mistake my heating to be thousands of degrees. Never mistake my heating, because I mean 40, 50, 60, 70, slight heating. Slight motivation is required for any reaction. 10 N2 plus P4O10. And you know another reactivity principle, P4O10, H3PO4, POCl3, these are all dehydrating agents. They don't do anything, they dehydrate people. I told you H3PO4 is a spectator, but I will say it's a dehydrating agent. So, what will happen? HC2HClO4 plus P4O10. What will happen? This fellow is a dehydrating agent, removes water, you get Cl2O7, because you know HClO4 plus HClO4 minus H2, anhydrate. I taught you how to find anhydrates, HClO4 plus HClO4 minus H2, plus when that P4O10 reacts with water, you get H3PO4. Of course, I haven't balanced it enough. Balancing is not important. Now, predict the reactivity. So, you can learn reactions only through predicting them. So, whenever you see a reaction, you tell yourself why that is happening. H2S plus K2Cr2O7, of course, solution. What will happen? H2S is in minimum, wants to give electrons. Chromium is in maximum, it is ready to come down. I am not saying it wants to come down, but I definitely can say it will come down. It does not wish to come down. Dichromate, there is no rule to come down. No one can demand it to come down, but K2Cr2 was even volunteers, branded oxidizing agent, he will come down. So, sulfur is in -2, chromium is in +6, sulfur goes up. In fact, sulfur is going up to +6, but when it reaches 0, it dies of a heart attack. Okay. Why? insoluble in water, sulfur, white, yellow, white turbidity, and Cr3 plus, whether it is chromic sulfate, don't bother, Cr3 plus is enough. Whether it is Cr2SO4 thrice, don't bother about spectators. KMnO4, I never want to call it KMnO4, it is a permanganate MnO4 minus. Okay, sodium oxalate, sodium is a nuisance for me. Sodium oxalate, that is the important. So when I ask you what do you see here, you don't have to tell me, sir, I am seeing Na2. If you are seeing Na2 means you are looking at unnecessary things. Stop doing that. So what do you see here? Sir, I see C2O4 2 minus. Remember, like somebody told in Mahabharata to have the target only see. When you are asked to shoot a bird, you should see only the eye of the bird, nothing else. You should not look at the tree, you should not look at the plants, you should not look at the branches, you should not look at the bird as such. You should target here only. That's a lesson to be learned. Na2C2O4, what are you seeing? Sir, I find oxalate here. I see oxalate only, that's all. And that is a reducing agent. So if I say Na2C2O4 plus KMnO4, don't bother with spectators. The nuisance factor, Na2. Throw him, K plus, kill him. Now I am happy. I am relieved of the burden because distinct role, spectators are out, only the players are left. So what do? You know their roles. Just as you know Tendulkar is a batsman, just as you know Kapil Dev is a bowler, you should know oxalate is a spectator. So, oxalate gives electrons, permanganate takes electrons, acid gives protons. Their roles are defined. They have defined roles. And I have defined the role of the species in my 20 reactivity principles. So this fellow is ready to give electrons, that fellow is ready to take electrons. Don't stand in between, let them do whatever they want. So oxalate, sir, wants to become carbon dioxide. All carbons in fact want to become carbon dioxide, and all carbons one day will become carbon dioxide. The carbons in this also will become carbon dioxide when I am burnt after a day. CO2, MnO4 minus, Mn2 plus, H2O. The question is how many? Oxalate can give only 2 electrons, but permanganate wants 5. What will you do? Okay, 2, 5. They have to strike an agreement. 2, 5. I can give you 2 only, but I want 5. So what they agree upon is, sir, 5 of us will come, 2 of you will come. Then what do you see here? This time you should not even see oxalate. When I ask you what do you see here? Sir, 10 electrons is what I like to get. 10 electrons. What do you see here? Somebody giving 10 electrons. What do you see here? Somebody taking 10 electrons. Achha. What do you find here? Somebody giving protons. Right. So 5 oxalates. Each oxalate will become 2 CO2 plus 2 electrons. It is the dream of all carbons to become CO2. Don't tell me why. Stable. Carbon dioxide is highly stable. 2 double bond O's. So 10 carbon dioxide you will get because each oxalate will give 2. So this is a pack of 10 electrons. What are you seeing? Somebody giving 10 electrons, somebody taking 10 electrons. You just watch that micro level. That micro level, looking at that micro level is chemistry, not looking at superficial things or things that are visible. You must see the invisible. Now, it's not a big thing. 2 Mn2 plus. Why manganese? Manganese, acidic medium always enjoys 5 electrons. Acidic medium. How many idlis can you eat? I can eat 5 idlis if sambar, with sambar. With chutney perhaps 3. With other media, neutral and basic medium 3. And some books will tell you basic medium 1, neutral medium 3, but 2011 the IITs have clarified in their official key. They have said 5 electrons in acidic medium, 3 electrons in neutral, 3 electrons in basic. It was a more than one correct question. You look at the official key given by the IIT. No doubt 1 electron initially and 2 more later, 2 more later. So, plus 7 to plus 6 to plus 4 in basic medium, step by step, but you have to tell me what happens eventually. What happens eventually. So, all doubts have been clarified. So, 10 electrons, 10 electrons. So, how many oxygens are not seen here? You have 20, 5 into 4, 20 oxygens, 2 into 4, 8 oxygens. Okay, 28, but only 20 are seen. 20 are seen. What happened to the 8 oxygens? Don't panic, don't panic. They become H2O. Okay, no one will simply disappear, especially atoms, they will not disappear. Professor John Dalton has said, atoms, you cannot destroy atoms. Sir, what happened to 8 oxygens? Don't panic, they reappear in the form of water. 8, 16 protons. So, each one has a defined role. Reducing agents give electrons, oxidizing agents take electrons, acids give protons. So, their ability is called their N factor, ability factor. What N factor means? Ability. Which ability? The ability they are known for. If I say the ability of Tendulkar is 50, what do I mean? On a given day, on an average, he can score 50 runs. Of course, there are occasions he made 200s and there are occasions he was out for a duck. But you should not talk about the extremes. On an average, most of the time. So, N factor of Tendulkar is 50, means you can expect 50 runs from Tendulkar. Oh, makes 200, fine, 0, okay, next time better luck. But on an average, similarly, permanganate can take 5 electrons in acidic medium. Oxalate gives 2 electrons. H2SO4, what is the ability? H2SO4 is an acid. What can you do? What can acids do? They can give protons. How many? 2. That is N factor. So, the undefined N factor is the ability factor, mind you. N factor means ability. Which ability? Which ability you look in a person? What ability you have to look in me? My running ability or my eating ability? You should not say, RSN sir cannot even run for 10 kilometers. I am not known for my running. If at all you want to see, you have to see my teaching ability. If I say my N factor is 6, what does it mean? My N factor, my ability is 6. What can that be? I can on an average teach 6 hours a day. I am not interested in teaching more. Something like that. So, that is what is called N factor, mind you. N factor is ability factor. So, the undefined N factor, ability factor. Now, so H2S wanted to go to plus 6, but dropped unfortunately when it got to 0, because, so this is yellow, green. So, you have no doubt got a green solution, but with a yellow precipitate. So, yellow green, you can't call it strictly green. So, gas that turns dichromate green. In fact, the language used is dichromate paper. Okay, dichromate solution green is, green means clear green. You can't strictly say this is green. Therefore, perhaps H2S is not the gas I have in mind. No, H2S is not the gas I have in mind. There is a gas that turns dichromate solution green. Green means green. No reference to any yellow thing. So, what could be that gas? Carbon dioxide. Carbon dioxide, will he turn dichromate paper green? Carbon dioxide is a spectator. So, what are the other gases you know? Methane. Oh, methane is a spectator again. Carbon is very happy in the company of hydrogens, it does not want anything. So, methane is not the gas I have in mind. Then what could be the gas? Carbon dioxide. Chlorine is an oxidizing agent. Here I want somebody to reduce, plus 6. So, fluorine is not the gas. Chlorine again is an oxidizing agent. Chlorine is an oxidizing agent. Fluorine. So, what are the gases? Nitrogen dioxide nitrogen dioxide. Nitrogen dioxide, yes, nitrogen dioxide may be able to reduce this nitrogen dioxide, but it is a colored gas. I didn't mention colorless gas. Colorless gas. Colorless gas. Oxalate can turn dichromate paper green, but oxalate is not a gas. Oxalate is a salt. Look at the troubles. Colorless gas that turns dichromate solution green. H2S can turn green, but with a tinge of yellowness. But I mention only green. Green. Carbon dioxide, no. Fluorine again is an oxidizing agent. You need a reducing gas. So dichromate green means +6 to +3. You need a reducing agent for this. So talk about a reducing gas. A gas that can reduce. HI can do that. HI, hydrogen iodide, can do that. But with violet vapors, iodine vapors, violet, I minus, colorless gas that turns dichromate solution green. So think of SO2, Cr +6, okay, what will happen? SO3 and Cr3 plus, but this SO3 is soluble, you get a sulfate, and sulfate is colorless. Therefore, you have got green and nothing else, pure green. So the only colorless gas that turns dichromate solution green is sulfur dioxide. That's why this is given as a clue in a question. Sir, how can I know there are hundreds of gases? You should not complain. You have to use your brain. What do you mean by turning dichromate paper green? Dichromate green, +6 to +3. It should be a reducing gas. It should be colorless. It should be able to act as a reducing agent. Who can act as a reducing agent? Minimum, intermediate. Intermediate oxidation state, sulfur -2 to +6. Sulfur here reducing agent only. Sulfur here oxidizing agent only. But when it is in intermediate oxidation +4, it can go up or down. It can do both. So SO2 can act as an oxidizing agent as well as a reducing agent. Yes, there are occasions when SO2 acts as oxidizing agent also. Look here. Next question. H2S plus SO2. So I am not giving a question and 4 options. I am giving open-ended questions. Discussing questions with 4 options is not very important. H2S plus SO2. Slight heating. What is expected? What is expected? H2S is a reducing agent. All oxygens want to become H2O. So H2O, 2 H2O, 2 oxygens are there, 2 H2O, for which you need 2 H2S. Take them. So you have 2 sulfurs here, 1 sulfur here. 3 sulfurs get precipitated. Don't tell me this is 3/8 S8. Don't. Here octoatomicity of sulfur is not important. 3S is enough. No doubt it is 3/8 S8. But you should not look for atomicity of sulfur in this question. You are deviating from the mainstream. Forget that. 3 sulfurs. Okay. So what happens here? Sulfur from -2 state goes to 0 and sulfur from +4 state comes to 0. Both of them, they drown when they come to 0 elementary state. They are not soluble. H2S plus SO2. So you take each principle and observe suitable examples for that. Last question perhaps. CuSO4 solution KCN excess. What is the first thing you should do is getting rid of the nuisance spectators, sulfate and potassium. Forget them. You have a copper 2 and you have a cyanide. See how relieved you are. Why should you unnecessarily talk about people who do not do anything at all? Rid of them, sulfate, potassium, spectators. Yes. What do you know about Cn minus? You have heard that cyanide is a spectator. Sorry. Cyanide is first a reducing agent and then a ligand. So cyanide reduces copper 2 to copper 1. Remember, when I say reduction, it is never copper 2 to copper 0. Oh my God, copper 2 to copper 0 is a very difficult process. What is that called? Metallurgy. Getting a metal in elementary state is next to impossible, for which you require special procedures we learn in metallurgy. This is a natural way, don't forget it, natural. Metallurgy is an unnatural process where you use lots of energies. So, here you are, copper to cyanide, copper to cyanide. So, there it is, copper to cyanide. What will happen? Copper 1. So, when we talk about reduction, you should talk from +3 to +2, +2 to +1, but never dream 0 in a natural way. Dream of some metals, of course, some metals will give. For example, silver oxide easily becomes silver. Even in a chemical reaction also, silver actually doesn't bother to take the electrons back. NaCl is ashamed of taking the electrons back. Even though Cl minus is ready to give electrons back, Cl minus definitely is not ready to give the electrons back. But even though Cl minus is ready to give electrons, sodium is ashamed to take. Sorry, I won't take what I have already given to you. I have given to you, I don't take it back. Suppose if I donate something to somebody, I will not claim that back. That doesn't look nice. But silver oxide is not ashamed. Okay, silver plus oxide minus. Oxide says, I will give your electrons back. He says, thank you. Thank you. Quite a shameless person. Oxide, silver. Oxide says, take your electrons back. Okay, no problem. Thank you. So, it doesn't happen with every metal. Metals are good reducing agents. They will give electrons. They will give electrons and they will never try to take them back also. It is very difficult to give electrons back to a metal ion and convert that to a metal, a science which is called metallurgy. Why you need so many techniques, carbon reduction, electrolytic reduction, this and that, and you have to put your life just to convert Al to O3 to Al. Getting aluminum out of bauxite is a very, very Herculean task, because aluminum doesn't take electrons easily. Aluminum ion, I mean Al3 plus. Oxide is not ready to give the electrons, aluminum is not ready to take. Arey, how can you meet a compromise? How can you make a compromise? You require a special process, and Hall Heroult did that. Hall Heroult, and before aluminum was extracted by Hall Heroult, kings and queens were said to be eating in aluminum plates and servants were served in gold and silver plates. Why? Aluminum was so rare at that time. Aluminum was so rare. Why? Because it's very difficult to convert an aluminum ion to aluminum. We have compounds of aluminum. We have many compounds of aluminum. You have alum Al2SO4 thrice. You have alum. You have many compounds. But compounds of aluminum, converting them to aluminum in elementary state is a science in itself called metallurgy. And here what you are doing is just normal reduction, natural. Okay. So, what will happen? 2 to 1. Okay. Copper 1. And cyanide, you know, is a strong ligand. So, CuCN4 3 minus. So, what change you observe? This is +2 to +1. +2 to +1 is what you need to observe. So, observe the change. This is my instruction. Observe the change. Change in what? Observe the change in oxidation state. Find out who is responsible. Find out who is responsible. Find out who is responsible for the change. Find out who else can be responsible. In an inorganic reaction, you just see, why is this happening? For example, FeSO4, KMnO4, H2SO4, all dilute, water, aqueous. You will be given Fe2SO4 thrice, unbalanced of course, 5, 5, don't worry about balancing right now, and maybe K2SO4, maybe MnSO4, and a lot of H2O. So, what is it you have to observe? Change. What change? Change in oxidation state of who? Anyone. +2 Iron is in plus 2, iron. That's why I spent considerable length of time in oxidation states, if you remember. I spent considerable length of time in oxidation states, plus 2, plus 3, plus 7 potassium, plus 2. Sorry, manganese, plus 7, plus 2. Okay. Plus 7 to plus 2. Who is responsible? Don't tell me manganese is responsible for this, because manganese is happy either in plus 7 or plus 2. It doesn't make any difference to manganese. He can happily stay in plus 7, he is equally happy in plus 2. But who is responsible? Iron 2 is responsible. Why? He has that requirement to become iron 2 to iron 3. I mean D6 to D5. He will get a better configuration. So he is more interested in giving electrons. Permanganate is not very highly interested in taking electrons. If you give electrons, he will take, but not that interested. He doesn't volunteer anything. Permanganate doesn't volunteer anything. So I will say ferrous sulfate is responsible. Ferrous sulfate no. Ferrous is responsible. So observe the change. Yes, sir, I observed plus 2 to plus 3, plus 7 to plus 2. Who is responsible? Iron 2 is responsible. Who else can be responsible? Find out who else can be responsible. Who else can be responsible? Sir, what type of a question is that? Plus 7 to plus 2, any reducing agent worth the name can do that. Any reducing agent. So, who else can do that? Sir, there is a long list of people. How can I say I minus can do that, Cn minus can do that? These are all reducing agents. Iron 2 is already doing that, H2S can do that, SO2 can do that, oh my god, oxalate can do that. There are a host of reducing agents, all these people can do. It is not just iron 2. Don't mistake that it is only iron 2 is responsible for that. There is a long list of people who are ready to lose electrons. Any metal can do that. Any metal can do that. I minus, Cn minus, Fe2 plus, H2S. Sn2 plus will gladly do that. Sn2 plus gladly. Okay. So even copper plus can do that. Copper plus is reducing. He wants to become copper 2. Copper 1 can do that. There are so many people. Find out who else can be responsible. Lost. Most important. Find out why somebody is doing what he is doing. Find out why somebody is doing what he is doing. Suppose if I am scratching my head, you see, why is he scratching his head? Somebody is biting his nails. Why is he biting his nails? Maybe he is nervous. Okay. Maybe he is thinking. So you have to find out. Ferrous is giving electrons. Why is he giving electrons? What benefit he will get by giving electrons? Nobody does anything without any benefit, you know. मतलब की दुनिया है. Nobody does anything without there is a benefit. If only you get some benefit out of it, you perhaps may volunteer. So here it is. Find out why somebody is doing what he is doing. Ferrous is giving electrons not out of love and affection towards you. Ferrous is giving electrons because it wants to get a stable configuration. The sun is giving us energy not out of any hamdardi, not out of any love and affection towards us human beings. He wants to get rid of the heat, otherwise he himself will become stable. Why the hell I am teaching? Why I am teaching? To get stability. What kind of stability? Okay, what kind of stability? Maybe when I get a few bucks, or maybe I get some kind of popularity. I don't know. And why are you studying of all people? Why are you studying 24 hours a day, 2, 4, 3, 6, 5? Why are you working so hard? You want to go to IIT. Why? Are you so mad about IIT? No. You need a package. That is it. Nobody does anything without anything. There are very few people. Yes, indeed there are some people. F minus donates. Why does it donate a pair of electrons? Does he have any need? Obviously no. F minus need not donate. He doesn't have any need. Donates out of compassion. out of compassion, no compulsion, but definitely there is a compassion. So, find out why somebody is doing, why is ammonia acting as a ligand, cobalt 3 plus, not just one ammonia, 6 ammonias like that, why? Does it mean that ammonia is mad about giving pair of electrons to cobalt 3 plus? It wants to get rid of the lone pair. Why is H2O2 giving oxygens to bacteria and killing bacteria? Does he have any animosity towards bacteria? Why is H2O2 removing color? H2O2 is he a person who doesn't like color? He wants to see the entire world in pure white, black and white? No, H2O2 wants to lose that oxygen atom because it is causing weakness to the structure. Oxygen peroxy bonds, they cause weakness to the structure. So, these 4 things you spend 10 minutes every day. 10 minutes every day. You open any chemistry book, any book for that matter. Look at reactions which do not involve too much of heat. You open any chemistry book, look at reactions which do not involve too much of heat. Too much of heat means more than 250 degrees centigrade, ignore. Anything can happen. More than 150 in organic, everything will happen. 150 breaks all, even carbon-carbon bonds. They are weak covalent, they don't withstand so much of heat. So, beyond 150, learning reactions is not any fun. There is no natural process. It's all what you call forced, in a way that is engineered reactions. They are engineered. They don't happen by themselves. Someone makes them happen. Now, not happening actually. Okay. If you follow this instruction, you will learn entire chemistry in 10 days. 10 days. 10 minutes every day. Open any chemistry book. Observe reactions taking place at a reasonably high temperature. Reasonably high means 100, 150, between 50 and 150. But 450, 700, anything will happen. So, that they are not natural reactions. So, and try to find out the principle involved. Some of the principles I might have told you, or I might not even have told you. You get to the principles. So, who taught me all these things? Who taught me all these things after all? I observed, I found out, I kind of what do you call generalized to minimize the effort one has to put in. Minimize the effort. If you have 100 years, okay, I mean 100 years for IIT, you indeed have 100 years of life, but not all 100 years for this preparation of IIT. You know your limitations, they are not my limitations. I can teach endlessly. I can teach endlessly. Don't think that I don't have, I have all the time in the world. I can teach any number of hours, and in fact, I don't have any other thing also. You have to take care of your mathematics, you have to take care of your physics, you have to take care of chemistry, you have to take care of your board exams, practicals, so many things you have, and you don't have time for everything. Me, I hardly teach for 6 hours a day, and I have 18 hours at my disposal, 18 hours. I can learn any bloody chemistry. I can read hundreds of time to read hundreds of books, and I can't pour all the information I find in them. Okay, you will find books, some books mentioning in cryptand 222, cryptands, sodium is in -1 oxidation state, minus, sodium minus. Please listen, I am not teaching anything, I am in fact unlearning what you have learned. If you by mistake you have learned, this takes place at -40 degrees. What doesn't take place at room temperature or a reasonable temperature is not as good as happening at all. So, don't forget that compound. Does sodium exhibit -1 oxidation state? You just ask, sir, are you mad? Are you mad? Metals exhibiting negative oxidation states? Get lost. That is enough for your level. Yes, that is an experimental compound, that is a research compound. You will have all the time after you are advanced to learn such things. If you are mad about learning chemistry, you do it after your advanced exam, but not before that. Don't play with fire. Don't play with fire. Learning such compounds is counterproductive to your health, not mine. Okay. So, do the natural things, krypton 222, HOF, fluorine forms oxyacids at minus 5 degrees, boron forms monochloride at minus 5, nothing. Boron is not monovalent, very rarely, it can be anything, it can be anything. The oxidation states of or the structure of K3CrO8, don't learn experimental compounds. What fun is there? Do you have that in your syllabus? Don't you have a defined syllabus? Don't you have a defined syllabus? Open the syllabus. Is this compound mentioned in NCERT? Don't take any interest. Okay, you have all the time. You have all the time after your advanced exam. You can do research if you are so mad about IIT. Okay, if I learn unnecessary things and they creep in my mind and by mistake I may use those in the class, but all these years I am conscious not to use such things. Maybe occasionally I make a mention of them only to warn my students to know their limitations, not my limitations.